Welcome to the ChopMan tutorial series. Based on the beloved classic arcade game Pac-Man, this project was created to be an easy-to-follow step-by-step guide that would give you the tools, techniques, and experience of creating a full game from start to finish. We have made all the original assets that we created for the game completely free. If you wish to follow along step by step, you will need to first download the ChopMan project files, both of which can be downloaded in the downloads area of the tutorial site or from links in the description. In this video, we'll not only show you how to set up the player character for the ChopMan game and create an automatic character blank, but we'll also be going over all the things you'll need to begin creating games with Bolt. For this project, instead of root motion or animations to drive the character's movement, we'll be using a combination of blend shapes, scripts, and triggers to cue the character's animation. For the first part of this video, we'll be setting up the state machine macro that can make our character automatically blink. This state machine is kind of a macro that we recommend that you save and not only use with this character in game, but for characters in any other game you develop. And while not 100% necessary for our game to function, small nuances such as this can easily help bring a character and game to life when viewed by the player. Something that you may have noticed in both our Chomp and Ghost characters is that they don't contain any native animations in the FBX files. Instead, they contain blend shapes. For those of you that are unfamiliar with what blend shapes are used in 3D to interpolate between different sets of geometry. Blend shapes are most often used in facial animation to transition between expressions or to make a character speak during dialogue. That said, we'll begin this video going over the basic install and setup of Bolt for those that are unfamiliar with it. For those of you that are familiar with the basic installation and setup of Bolt, feel free to skip ahead to the timestamp shown on the video. As of July 2020, Bolt is now officially a part of Unity and is completely free to download and use in current or future projects. To download Bolt, simply go into your package manager or the asset store, download the package, and import it into your project. Once Bolt has been successfully imported into your project, you should automatically be introduced to the Bolt setup wizard. If Bolt was successfully imported and for whatever reason you don't see the setup wizard, you can access it by going to Tools, Bolt, Setup Wizard. With the setup wizard up, click Next to go to the naming scheme window. For this project, we'll use human naming. However, if you are more familiar with writing code and proper syntax, you may feel more comfortable with programmer naming to get a more precise naming convention. We'll simply click Next for the Generate Custom Inspector, Assembly Options, and Type Options windows. However, the more you use and feel comfortable with Bolt, the more you'll feel comfortable with specifying the options in these windows. Once Bolt has finished its initial setup, feel free to click Close or explore the online documentation manual. Next, let's set up the different windows or panels we'll be using with Bolt. First, in the Windows dropdown, click and open the graph. In Bolt, you utilize and use graphs for everything you create. So essentially, it will be where all of our logic is designed. Since this will be such an important part of your Bolt project, we recommend you dock this window and make it a forefront part of your layout if you're not utilizing multiple screens. Next, bring up the Graph Inspector, which, like its name implies, when items are selected on our graph, the Graph Inspector will allow us to inspect details about them. Last but not least, we'll open the Variable window. The Variable window will allow us to create, alter, and view the variables in our graph, project, or scene. Once we have all of our Bolt windows up and placed within the Unity editor, we recommend you save your layout, which will allow you to quickly and easily access and place your new windows for any future Bolt projects. With our Bolt setup and windows displayed and placed in our editor window, let's begin creating the blink for our character. Since we'll be making a prefab of our character, we don't need to add our character to our level 01 scene just yet. So open a blank scene and drag the Chomp character into the hierarchy. The Chomp character can be found in the Mesh folder under the Character subfolder. With our character now in our empty scene, let's reposition the camera so we can view the front of our character in our game view. By selecting the character and hitting the F key, Unity will automatically focus or frame a selected object in the editor viewport. With our character selected, if we click Add Component and select the Bolt dropdown, you'll notice we have two types of machine graphs we can use. For those new to Bolt, in any project, Bolt contains two different types of graphs that you can take advantage of: flow machines and state machines. Throughout the project, we'll show you how to use both. However, for this character action, we'll simply be using a state machine. With that said, click and add the state machine component. You should now have two additional components, a variable component and a state machine component. To begin, we need to first create a macro file to store our graph data. Let's first create a folder we'll call macros that we'll use to store all the different macro files that we'll create throughout this project. With our macro folder created and the Chomp character selected, click the New button on the state machine component. We'll name the file Blinking Macro and save it in our newly created macros folder. With our macro file created, if we now go back to our graph, we can see that we now see the bases of our state machine in Bolt. By double-clicking our Start state machine inside of our graph, we can see the flow graph inside. So for those of you that have used flow graphs in Bolt, the easiest way of thinking about state machines in terms of how they're used in Bolt is like containers that house individual flow graphs. Something to note is, at the top of the graph, Bolt gives us a breadcrumb trail, and we can use this to go in and out of our different states. In the Chomp Mesh main state, if we right-click on an empty area of our graph, we can create one of three states. We can create a flow state, a super state, or an any state. To begin, create a super state. A super state is a state that can house other states and a great way of housing and organizing macros that will have multiple unique state machines. Once we have that state created, right-click the super state and click Toggle Start. At this point, your super state should now be highlighted in green. Bolt uses this color as a fast way to indicate starting states or nodes. Next, delete the start state and rename the super state to Blink SS. To rename a state, select it and inside the graph inspector at the top, type the name into the title text box. Once the super state is renamed, double-click the state or click Edit Graph in the graph inspector to open the super state. In the super state, we can see the default start state. Something to note is, when we're outside of our states, we can see the state contains a start event, exit event, and an update event. Since we'll just be using the start event, we can delete the update and exit event. If we now leave our state, we can see Bolt will indicate that we no longer have an update or exit event. To begin, the first thing we need to do is store our character as well as the character's skin mesh renderer inside a variable. The skin mesh renderer is the component that houses our blend shapes, so we'll need to be able to access it in order to manipulate the blend shapes within it. In the variable window, we can see Bolt gives us several kinds of variables we can create. We can create graph variables, object variables, scene variables, application variables, and saved variables. And while in this video, we won't overwhelm you with the unique specifics and applications of each type, throughout this project, we'll mainly be focused on using the graph, object, and scene variables. However, in this video, we'll simply be using the scene variable, but it will work in any of the variable types as well. First, we'll create two variables, one called character and one called character mesh render. To create a variable, you simply need to first define its name, then click the plus button beside it. Something to know about variables in Bolt is, unlike in C#, variables in Bolt aren't strong typed. This means even if you define their type, unless they are housing an object of that type, they are simply stored as objects. For example, we'll set the character variable to be a game object variable, and the character mesh render to be a skin mesh render variable. However, if we hit play, we can see that our variable's type is set to null. Additionally, when we leave play mode, the variable type is null. But if we not only set the type, but also pass in a value, in this instance, we'll use our chomp character as the game object value and then hit play. Bolt now holds both our variable type and our value. Even as we leave play mode, we can see that while our variable is once again set to null, our character variable retains its variable type. So essentially, when you create your variables and set the type, if there is no object or no value, Bolt will simply read it as an empty object variable. And while we do understand, for those of you with programming knowledge or experience, this can take a while to get used to. It's something that's extremely important to be aware of when working with Bolt. With that in mind, we'll remove our chomp character from our character value since we'll be setting it through our graph. We'll begin by left-clicking the arrow on the On Enter state. When we let go of the left mouse button, we will get our unit or node search window. Type Set Character and click the Set Character node. Once you create a variable, Bolt automatically creates a Get and Set node specific to that variable. Additionally, if we right-click on our graph and bring up our unit search window and type Set Variable, you can also find the variables you've created in the dropdown in the Set Variable node. You may have also noticed the new Set Variable node we just created isn't attached to any event or node. By clicking the arrow on an event or node, then dragging it and using it to access the unit search window, the node will automatically be connected to that event or node. So now that we have our Set Variable node, we need to set what we want to pass in as our value. And what we want to pass in is the game object that houses our graph, which is the self node. One of the great things about visual scripting is it allows us to quickly test everything we do without having to compile each time. It also allows us to visually see what each node is doing, so we can easily tell when something's going wrong. So let's hit play and test our state machine so far. If we look in our variable window, we can see that our chomp character is now the character value and its variable type is now game object. So let's continue developing our start state by now setting the character mesh render variable. To do that, we need to get the child of our character variable, then get its skin mesh renderer and set it as our character mesh render value. To do this, create a getChild node. Next, pass in the character value from the set variable node. The index is what identifies which child the node is getting. The easiest way to think of the index is in terms of an array. And just like an array, the first object is 0, then 1, 2, 3, and so forth. Since the chomp mesh is the first child, its index is 0. Next, we'll use a getComponent node. Then set it to get the skin mesh renderer component. Last but not least, we need to use our getComponent node to set our character mesh render variable and pass the getComponent node into our variable. Now that we have all our variables set to receive their proper values, let's hit play to test it out. Since our start state is now complete, let's go back to our main superstate and create a state for our blink functionality. Before we begin, let's first create the core logic we'll need to make our character blink. First, create a set blend shape node. In the set blend shape node, we have a target, index, and value. Like the getChild node, the index is the number in the order of our blend shape. For our character's eyes to close, the blend shape value will need to be 100. And the target is the character mesh render variable we set in our start state. By dragging the variable into our graph from the variable window, Bolt will automatically create a getVariable node for the selected variable. With our basic logic set and in place, if you were to click play now to test it, you will find that despite the fact that the variables are still being set and Bolt hasn't sent an error notification, your new state still doesn't seem to be working. If we go back to the main superstate graph, you may notice that while the start state is highlighted in blue, the new state is grayed out. The reason the new state won't work is because states need transitions in order to be active. To create a transition, right-click the start state and choose Make Transition and drag the transition to the new state. You should now have a line connecting the two state machines with a hexagon in the middle. The hexagon represents a transition event. A transition event is an indicator on what needs to happen for it to go to the next state. If we go into our transition event, we can see we have a start transition, but nothing is connecting to it. Since we're only using our start to set our variables, we can use a start event node to automatically transition to our next state. If we go back to our superstate graph, we can see we now have a green checkmark over our transition, which is Bolt telling us that we have a successful transition event. With our transition established, let's hit play in the Unity editor. At this point, we've both set our variables as well as used them to make our character's eyes closed. We can see the core functionality of our state machine will be setting the blend shape value to 100, then back to 0 to open the character's eyes. However, we don't want it to simply snap to 100 or 0. We want it to be a quick but gradual transition. We also want there to be a pause or wait between blinks. With that said, let's first rename our state to blink, then go into the blink state graph. First, we need a float variable to represent our current blend shape weight. Second, we need 2 additional floats to represent the weight minimum, which is 0, and the weight maximum, which is 100. Third, we need 2 more additional floats to represent the character's blink speed, and another to represent the amount of time between blinks. With that said, let's begin creating our first set of float variables. For our first float, we're going to name it blink weight. Our second float will be named blink speed. Our third float will be named max blink weight. And our fourth will be min blink weight. Lastly, we'll create one more float variable that we'll name blink pause. Certain variables will automatically have a value when you create and set their variable type. For example, when we set the variables to be a float, they are given a value of 0. 0 is technically a value, so unlike game objects, if you enter play mode, they will still keep their variable type. In addition, since we've established 100 is the maximum value of a blend shape, set the max blend weight to equal 100. Likewise, set the min blend weight to equal 0. With all of our variables now created, let's begin to create our character blink. In order to make the eyes gradually shut, we'll use a node called getDeltaTime. Next, we'll add the delta time into the blink weight to make it increase in value. Then use that to set our new blink weight. Since we need this to happen every frame, we're going to connect this to our update event. Next, we want to set our blend shape weight to the blink weight. Before we continue, let's test out what we've created so far. One of the great things about visual scripting is it allows us to see in real time all our values even as they change. Though our state machine seems to be working correctly, at this point we can see using delta time alone will only allow our character to blink far too slowly for our game. With that in mind, by using the blink speed variable we created, we can both speed up or slow down our character's blink. In order to do this, we need to multiply our blink speed by the delta time. Since we still don't know how fast our blink needs to be, we can temporarily set it at 20, then tweak the number while in play mode during runtime. For now, we'll set our blink speed to about 500. But once all our states are in place, it will be a lot easier to gauge our blink speed, and we can make further tweaks. That being said, let's go back to our main blink super state, duplicate our blinking state, and rename the duplicate to opening. Since we've already created all of our logic for the eyes to open, by simply replacing the add node with a subtract node, we can make the character's eyes reopen. With our opening state complete, let's go into our main blink super state and create a transition from the blinking to the opening state. Next, go into your new transition graph. So unlike the last transition, we don't want it to simply start the moment the blinking state begins. Instead, we only want to transition once our blink weight is the same or greater than our max blink weight. In order to do this, we need a greater or equal to node, which is under the logic section in the unit search menu. Next, we need to place our blink weight and max blink weight into the greater or equal node. Next, we need to create a branch node. The branch unit is a node that allows us to choose which actions to take based on the results of our logic. In our case, we only want the state to transition if it's true. Lastly, we'll need to create an update event, which will not only start our branch node, but also constantly check to see when blink weight is greater or equal to the max weight. Before you go back to the blink super graph, copy all the nodes in the transition graph. Next, create a transition from the blinking state to the opening state. Inside the new transition graph, delete the trigger transition and paste the nodes from the other transition into this one. Replace the max blink weight variable with the min blink weight variable. Additionally, delete the greater or equal node and replace it with a less or equal node. With that complete, let's test our state machine in play mode before completing our last step. We can see our character now gradually opens and closes his eyes. However, at the moment, the character continuously does this without a break or pause. In order to create a pause, go back into the less or equal transition graph. Next, add a wait for seconds node. In the wait for seconds node, connect the blink pause to the delay. Branch to the wait node, then connect the wait node to the transition state. Despite the fact all of our nodes are in place, if we were to try and test it now, we would get a red error message. The reason for this is due to the fact wait for seconds is an operation that can only be utilized in coroutine. So we'll need to make this transition a coroutine in order to use the wait for seconds node. In order to do this, simply select the update event and in your graph inspector window, check the coroutine box. With our state machine now complete, let's go into play mode and test it out. For the final step, create a prefab of the Chomp character by dragging him into the character subfolder in the prefab folder. If you don't have a character subfolder, you can easily create a folder just by clicking anywhere in the project window and selecting Create Folder. In the second part of this video, we'll do the base setup of our Chomp character for our game. With the character prefab selected, at the top left part of the inspector, inside the dropdown, select Player. Player is a default tag which is included in Unity. But in the next lesson, we'll go over how to create your own custom tags for those that are unfamiliar with the process. With the character now tagged, go to Open Prefab. First, since we won't have any animations for our characters aside from our blend shapes, remove the animator component for the character. Next, add a character controller component. On the character controller, move the height to 1 and make the radius and the center y-axis 0.6. Next, add a sphere collider component. Make its y-axis 0.6 and its radius 0.65. Since the character controller will act as our physics collider, set the sphere collider to isTrigger. Save the prefab, and by dragging it into our scene, we can now see our character has both the character controller, spherical trigger collider, and the blink script. That completes our player character setup. In the next video, we'll set up our enemy characters creating a dynamic floating effect that allows them to glow and dynamically change colors with a single material. So be sure to join us in our next lesson